Hi, this is Anusha R from Artificial Intelligence and Data Science Department, currently presenting my project work phase 2 on Agri crop quality detection using deep learning model. And this project is submitted by myself Anusha R and my team members Shajit and Vismaya S. And under the guidance of Dr. G. Lavanya, our mentor. An agenda includes introduction, statement of the problem, scope of the project, methodology, output results, test cases, conclusion, future work, and references. The introduction that highlights the project's goal of identifying plant disease through image processing techniques. The system captures high-resolution image, pre-process them, and utilize deep learning to detect disease, providing early warnings to the farmers to prevent further damage. This also checks the quality of the leaf. The problem statement emphasizes the importance of improving crop quality for economic growth, as a traditional disease detection methods are time consuming and require constant monitoring. AI driven solutions have shown significant improvements in both speed and accuracy. The project scope includes developing a deep learning model for accurate crop quality detection, with the target audience being farmers, agricultural researchers, and agri-tech companies. Deliverables include a trained model, a user-friendly interface, and a documentation. However, the system does not cover all crop types, lacks real-time monitoring, and may face challenges in generalizing across varying environmental conditions. The scope of the project, which includes the data limitations and other limitations in the project, and the methodology involves multiple stages of the project, which are data collection, image pre-processing, which includes resizing, noise reduction, content enhancement, color normalization, and image segmentation such as k-means clustering, thresholding methods, and edge detection. At last, the feature extraction, the color feature, texture feature, and shape feature. And at last, the model development includes the disease classification using CNN, SVM, and artificial neural network (ANN). The methodology involves these stages: data collected from agricultural fields and research data set, image processing techniques like resizing and noise reduction, and disease classification is carried out using deep learning models such as convolutional neural network (CNN), support vector mechanism (SVM), and artificial neural network (ANN). And these models learn from labeled dataset and identify plant disease with high accuracy. The system's design include diagrams like use case diagram and entity relationship diagram and class diagram to illustrate the system components and interaction. In this architecture diagram, where we include the database or data set, and the data set is classified into test and training data sets and trained to the model, and where the image is augmented and a feature is extracted and feature is selected and given to the model for the classification of the disease. And at last, we can give the web interface using the Django deploy. The use case diagram, UML diagram, includes a case diagram where the actor set of use cases enclosed by the system boundary, communication association between the actors and users, and generalization among use cases. The use case model defines the outside and inside of the system behavior. The ER diagram gives the entity relationship diagram, which graphically represent the information system that depicts the relation among people, object, and places. The design class diagram is a representation of the template from which objects are created. And this is a sequence diagram of the project. The algorithms used in this project are convolutional neural network, and it identifies plant disease with high accuracy. And another algorithm used here is support vector mechanism. It also used for the binary classification of healthy and diseased plants. And at last, the hardware and software selection. The hardware and software selection part is the most important part, as it uh, includes many important things, and which includes RGB color sensors, NIR sensors, IoT enabled microcontrollers, and cloud based platforms like ThinkSpeak and for data collection and monitoring. Implementation is carried out by the Python using libraries like OpenCV and PyTorch. The dataset is stored in the Google Drive, pre-processed and used to train the model. The trained model analyzes image, detects crops quality, and labels crops as fresh, rotten, and diseased. The project includes key code segment for dataset pre-processing and genetic algorithm-based selection and fitness evaluation. And this is the code for the project. At last, it gives the output of this. And this is the final output where the model predicts the disease of the plant, and it gives us a name from the data set. The results are evaluated using accuracy, precision, recall, and F1 score, ensuring the model performs well in classifying crop quality. The test case verifies the model's prediction on healthy and diseased leaves with the confidence score and indicating the reliability of classification. And this is the test case 1, and this is test case 2. And this gives the test case 3. As a result, it is based on the accuracy, precision, recall, and FN scores, which is accurate value of 96.3, 94.8, 95.2, and 95.0. As a conclusion, the project demonstrates that the machine learning and image processing significantly enhance plant disease detection, helping farmers take timely action. CNN provides to be the most effective classification method, and though improvements can be made, future work includes integrating IoT-based real-time monitoring using sensors for environmental tracking and improving model tracking accuracy with transformer-based architecture. Additionally, the expanding system to support multiple crop types will make sure more robust and widely applicable. The presentation ends with the reference citing research sources that contribute to the project. Thank you.